Okay, today we're looking at proving triangles congruent. We're going to look at how we can prove that two triangles are congruent, giving some of the information of the triangle. Our first example right here, we are looking at this triangle on the left, these two triangles. Notice that we have these sides congruent. Well, if all three sides are congruent, then we can say the triangle is congruent because of side, side, side. In the second example, we look at that triangle, and this can be proven because of angle, angle, side. Notice that this angle is congruent to this angle congruent to this angle. So we read this as angle, angle, side. Here's the angle that's congruent. There's the next angle that's congruent. There's the side. That's where we get side, or angle, angle, side. Now if we started from the side first, well, if we did that, we would get side, angle, angle. But just understand that we don't write it that way. It's the same thing as this, but the way we write that is angle, angle, side. Okay. This one, we're starting here, we're going around, we get side, angle, side. So if we have side, angle, side, then we can say that these two triangles are congruent to each other, even though we don't know what the angles are here or the side length here. If we just have side, angle, side, we know that they're congruent. And the last question is angle, side, angle. There are a couple of those that are missing. For instance, angle, you'll notice that angle, angle, angle is not an option. It doesn't prove triangles congruent because if I have an equiangular triangle, all the angles are 60 degrees, then I have a larger equiangular, they're all 60 degrees. So if these three angles were congruent, doesn't mean the triangles are congruent, which is why we don't use that. Another one that we have is SSA. We don't have side, side, angle, or as some people call it, angle, side, side. Just know that when we see that, those are not ways to prove triangles congruent. Okay, so let's look at these examples. We want to state if the two triangles can be proven to be congruent. If they are, we'll state how. Now remember, on some of these we have vertical angles, so these aren't marked as congruent, but they are congruent. Now this is angle, angle, angle. That is not a way to prove triangles congruent, so no, we cannot prove those triangles congruent. Number two, they share this side, so what we have here are triangles that have three sides that are congruent. That is a way of proving triangles congruent, so the answer is yes. Number three, we have a side and an angle, but nothing else. So the answer is no, because we need more information than just angle, side, or side, angle. Number four, we have side, angle, side. So yes, that is a way to prove triangles congruent. And number five, this segment is congruent because they share it, which leaves us with side, angle, side. So yes, that can also be proven congruent. Okay, let's look at the other problems from our notes. Same question. Remember, we have vertical angles here. So what we have are angle, side, angle. And angle, side, angle does prove triangles congruent, so my answer is yes, that can be proven. Number two, we have angle, angle, angle. We already said no, that's not a way to prove triangles congruent. We have vertical angles, so those two are right angles, they're congruent. So here we have side, side, angle. That was not one of our 4 ways of proving triangles congruent, so the answer would be no. Number 4, they share the segment, so we have angle, side, angle. Yes, that is one of our 4 ways of proving triangles congruent. Number 5, vertical angles are congruent. So what we end up here is angle, angle, side. Angle, angle, side is one of those 4 ways of doing that, so yes. Okay, so remember, when looking at this, these are the 4 ways that we can prove triangles to be congruent. Okay, right triangles. If we have a right triangle and we have the legs congruent, then the triangles are going to be congruent. But of course we know this as side, angle, side. If we have a right triangle and we have an angle and the hypotenuse, then the triangles are going to be congruent. Again, we know this as angle, angle, side. So we wouldn't have to write anything other than angle, angle, side for this one. And the same for side, angle, side here. Now if we had a triangle and we had angle and a leg and an angle. Remember, legs are the sides that make up the right angle. Hypotenuse is the side opposite the right angle. But if we had this, well, we still would have angle, angle, side, which is one way of proving that congruent. Now this is where it gets interesting, because if I have a right angle and I have a leg and a hypotenuse, this is side, side, angle. Well, we've been saying that that's not a way to prove triangles congruent, and it's really not, except for when they're right triangles, then it works. So what we have is side, side, angle only works in right triangles, and we call it HL, hypotenuse leg. And I'll zoom in and kind of write the term for that. If the hypotenuse and one leg of right triangles are congruent, then the triangles are congruent. So what that's basically saying is if I have 2 right triangles, the hypotenuses are congruent and the leg are congruent, one leg is congruent, then we can prove that the 2 triangles are congruent using hypotenuse leg, HO. So what 3 things have to be true to be proven or true before you can use the HL congruence? Well, you need 2 triangles, 2 right triangles. Hypotenuse has to be congruent, and one leg has to be congruent. Okay, looking at 1, 2, 3, and 4, these are going to be just like your problems on your homework assignment. Notice vertical angles, they're going to be congruent, so what we end up with is angle, angle, side. Can these be proven congruent using angle, angle, side? Yes. Number 2, we've got vertical angles. So this leaves us with side, angle, side. Can triangles be proven congruent with side, angle, side? Yes. Look at 3. We have nothing else that's congruent, so we have angle side or side angle. That's not enough information to prove them congruent. And then in 4 we have side, side, side. That is a way to prove triangles congruent. Okay, 5, 6, 7, and 8 are very similar to the problems you'll see in your assignments on 16 through 20 or 30. So let's look at this. All right, we're finding what additional information is required to know that the triangles are congruent using this. Then we're going to write a triangle congruent statement. So let's look at this. We have right angles, so remember we need 3 things. We need the right angle to be congruent. They share this side, which is a leg. So we have one leg congruent. We have 2 right angles. The last thing we need is the hypotenuse to be congruent. Well, here's the hypotenuse to this triangle, and here's the hypotenuse to this triangle. So we would say that fx needs to be congruent to wv. Now we need to write a congruent statement, so we're going to say triangle fwx is congruent to triangle. Be very careful here. We can't just list anything. We have to label corresponding parts. F is corresponding to, in this case, V. So we have to start our next answer with V. W in this triangle here is corresponding to X. So X would go next, and then W, X corresponds to W. So that would be my answer for number 5. Okay, number 6. We were proving this with angle, angle, side. Remember, they share this side, so that's going to be congruent. We need one more angle because we have an angle. Let's go ahead and say that this angle has to be congruent to this angle, since that would be a corresponding angle for it. Be careful what we say here, because we can't say angle X if we're talking about this angle, because angle that could be several different angles. So we have to name this as YXW. So YXW is congruent to angle, and the other angle we're talking about is this one, has to be XWC. Okay, so those 2 angles have to be congruent to prove they're congruent with AAS. So now we're going to write the triangle congruent segment. We'll say WXC is congruent to triangle. What corresponds to W? That would be this angle right here, which would be X. What corresponds to X? That would be this one that's not labeled. Well, it's going to be congruent to this angle. So that would be W in that vertex. And then C would be corresponding to Y. Okay, looking at number 7. We're going to use angle, angle, side again. Remember, they share this side, so that's congruent. Angle, angle, side. Well, if H was congruent to A, we would have angle, angle, side. So yes, we would have to say angle A, which we can use a single letter because there's only one possible angle we could be talking about when we say angle A. Angle A and angle H. Now our triangle congruent statement, triangle AIJ is congruent to triangle corresponding to A would be H. I would be corresponding to, now I of this triangle would be corresponding to J in this triangle. So J, and then J would be corresponding to I. And the last problem, we would have, prove it with side, side, side. All the sides have to be congruent, so this segment has to be congruent to this one. So US is congruent to GE. Now, if that's the case, then we can prove the triangles are congruent, so our congruent statement is going to be triangle UTS is congruent to triangle. U corresponds to E. T corresponds to F. And S corresponds to G. How do I know that? Notice that T is in between the segments that have the 2 tally marks and the 3 tally marks. So T corresponds to F because it's between the segments with 2 tally marks and 3 tally marks.